In these problems, we're working on identifying graphs of quadratics. And you should know the mother function here, y equals x squared, and you should know what that looks like. Y equals x squared is going to have the point 0, 0 here as its vertex. It opens upward, and it goes on out like that. So that's our basic starting point. When we do other things to it, the shape will change slightly. For example, if you put a negative number in front of the x squared term, it'll flip over and point downward. If you put, well, in this case, if you put a 4 in front of it, that's a positive 4, so it's still going to open upward like this one, but it's going to rise much faster, and the result it'll be skinnier. And then if you put a plus 3 on there like that, it's actually going to move the whole graph up 3. So I'm thinking C is our correct graph here, but it's good to check. I see there's the point 0, 3 on here. If I put a 0 in for x, I get 3 for y. Yes, that checks. So C is going to be our answer. Let's take a look at a slightly more complicated looking one. Now this one, they've actually got it in this sort of factored form, and you could multiply all that out, but we really don't have to. One thing to notice is there's a positive 4 on the outside. That's going to be the term that comes along with the x squared term, so it's going to open upward. So this one's out. That 4 is going to make it skinnier. It's going to rise faster. If this was a 1/4 or a 1/2, it would make it shallower. So I know this one's going to be looking kind of skinny, so I'm suspecting it might be C. But I want to check a point on this graph. I notice there's the point 5, 0. If I put in 5 for x, that would be 5 minus 5. And 5 minus 5, so 0 times 0. That would give me 0. So the point 5, 0 checks out. I think it's got to be C. Let's try one more. All right, this one looks complicated. We've got negative 4x squared plus 3x minus 4. It's got a negative number in front of the x squared term, so it's going to open downward. That doesn't help us too much. All of these open downward. And then, well, it's hard to tell because it's got this x term in. I think it's going to be translated down a little bit, so I doubt it's B because it's got this negative 4 out here, but it's hard to tell. So here's one handy thing. An important point on any parabola, on any quadratic, is the vertex. And the formula for the x-coordinate of the vertex is negative b over 2a. In this case, that would be negative 3 over 2 times negative 4, or negative 8. And that is a positive 3/8. So I would want to look for where the vertex has a positive 3/8. And it looks like it could be this one. X is positive 3/8 there at the vertex. Or I guess it could be this one, although I was thinking it wasn't going to be B. Definitely won't be C, because that looks like it's more maybe a negative 3/8. And what we could do then, if we really wanted to verify here, we could pop in the 3/8 for x and crunch this out, although that looks like a little bit of work. Another thing to do is actually to try to solve it and see where the solutions are, because the solutions of this are where the parabola would cross the x-axis. And you'll notice there's 2 of them here. So this one, if it's right, it would have 2 real solutions, or real roots. This one doesn't have any, so these would be imaginary roots. So let's check the discriminant. Remember, the discriminant is b squared minus 4ac. Well, in this case, that would be 9 minus 4 times negative 4 times negative 4. That's going to be 9 minus 64. That's definitely going to be a negative number. That means 2 imaginary roots, so it fits with this one. So that's a little bit of work with recognizing the graphs of quadratics. My name is Larry. I'm a teacher at EdVision's off campus. It's an online project-based school in Minnesota. If you're interested, you can check us out on the web at lovethischool.org. Thanks.